In this video, we're going to talk about how to create a quadratic function given the roots. So that's called the sum and product of roots. And it's just like it says, first you find the sum of the roots, and then the product of the roots, and then you put them together. So in this first example, our roots are -3/8 and 5. So the first thing I'm going to do is add them. That's where the sum part comes in. And you can just use your calculator when you do this. Of course, you got to make sure you use parentheses around your fraction. Oops. So we got -3/8 here plus 5, which is 37/8. And you guys will see in a second why we need to use fractions here. Now 37/8, that is always equal to -b/a. So when you add the roots, the denominator is equal to a, and the numerator is equal to -b. Of course, we want to turn that into a positive. So if that's a -b, then -37 would be a positive b, and of course 8 is still a. So that's the sum of our roots. Now we're going to take the product of our roots. So we're going to multiply these two numbers now. So I have -3/8 times 5. Again, make it a fraction, which is -15/8. So this equals -15/8. And that is equal to c/a. So that means -15 is c, and 8 is a. So we found the sum of the roots, we found the product of the roots. Now what we need to do is make sure that our a value is the same on both of these. So these are both 8, which is good, so we don't need to do anything there. So now we'll just write this out. A is 8, b is -37, and c is -15. And you should remember that the general form of a quadratic is ax squared plus bx plus c. So all I'm going to do is substitute those numbers in now. So I have 8x squared minus 37x minus 15. So this function has roots of -3/8 and 5. And given those roots, we were able to work backwards and get our function here. We'll try a couple more. Let's say we have -1/4 and -1/2 for our roots. Again, the first thing you're going to do is add them. So we have -1/4 plus -1/2. Again, notice how I have parentheses. So we have -1/4 plus -1/2. Change it to a fraction, gives me -3/4. So this is -3/4. Again, that equals -b/a. I want a positive b, so that means I need to change that -3 into a positive 3, because it's the opposite, so that I can get a positive b here, over 4. So -3 was -b, which means positive 3 is a positive b, and 4 is a. Now we'll multiply these roots. If you punch that in your calculator, you will get 1/8, and again that equals c/a. So 1 is c and 8 is a. Next thing we do is check to see if our denominators are the same here, because we need the same a value. They're not. So what we need to do is get a common denominator. So if we have 1/8 here, it's very easy to turn this 4 into an 8. All I have to do is multiply it by 2. So I need to multiply the top and the bottom by 2. So I'm going to take 3 times 2 here, which is 6, and then 4 times 2, which is 8. And so that is now my new b/a, because now our denominators match here. So we have the same a value here. Notice my b did change, and now a is 8 for both. So a is 8, b is 6 now, not this 3/4, we don't need that anymore. So b is 6, and c is 1. Again, we'll put that in our form, so we have 8x squared plus 6x plus 1. Alright, let's do another one. Let's say we have one with imaginary numbers this time. So we have 5 plus or minus I radical 3. That plus or minus, of course, means that you have a plus and a minus one. So when I find the sum, I'll have 5 plus I square root of 3. Then we add that to 5 minus I square root of 3. I'll put that in parentheses to help you out there. You should remember from your operations of complex numbers that we're just going to combine our like terms. So I'm going to have 5 plus 5 here, which is 10. And then we have a positive I square root of 3 and a negative I square root of 3. That makes 0, so all I have is 10. Of course, 10 is a whole number, and we need everything as a fraction, which means 1 is our denominator. Again, that equals negative b over a. So if 10 is negative b, then negative 10 is the positive b that we need, and a is still 1. Now we will multiply these roots. So we have 5 plus I square root of 3 times 5 minus I square root of 3. We'll distribute. 5 times 5 is 25. Then we have minus 5I square root of 3 plus 5I square root of 3. And this last term gives you minus I squared square root of 3 squared. If we simplify that, this whole term disappears, becomes a 0. So we have 25. I squared is negative 1, so we've got this minus out here, times that negative 1, and then the square root of 3 squared. Those are inverses, so we just have a 3. So again, our middle term disappeared, and it always will disappear. Then we have minus I squared, and then remember I squared is negative 1, and then the square root of 3 squared, which is just a 3 here. So 25 minus negative 1 times 3, a negative and a negative make a positive. So we basically have 25 plus 3 here, which is 28. That's a whole number, so again we got to put it over 1, and that's equal to c over a. So 28 is C and 1 is A. The next step is to make sure that our A value is the same. That's a 1 and that's a 1, so A is the same. So we have A is 1, B is negative 10, and C is 28. So our equation is x squared minus 10x plus 28. And of course, if you wanted to double check, you could just factor that, and you will see that you will get this root of 5 plus or minus I square root of 3.